Hello, welcome to The Extraordinaire, where we are committed to the relentless pursuit of excellence. If you like tech, you want to skill up, or you just love learning new things, subscribe to the channel and make sure you click on that bell icon so you don't miss any of our contents. Today we are going to be looking at fancier output formatting. Basically, how do we format our output in the way that we want it to be? So far we've encountered two ways of writing values: expression statements and the print function. A third way is using the write function or the write method of file object. The standard output file can be referenced as sys.standardout. Often you will want more control over formatting of the output than simply printing space separated values. There are several ways to format output. You can do so using formatted string literals, the format method of strings, or you can do it manually. Let's take a brief example of what those three look like. I'll create a new example file here. Let's call this example 1.py, and here I want to format the string using the formatted string letters, which is being done by adding a uppercase F or lowercase f before the opening quotation mark or triple quotation mark. Inside the string, you can write a Python expression between opening and closing curly braces, which refer to variables or literal values. So in this example, we have a variable defined as the year, and we'll give that, we'll assign it 2016, and we have an event which will be assigned the value referendum. Then we can now print results of the year and event. Notice how we put the variables in between opening and closing curly braces, and notice that there is the f in front of our opening and closing quotation mark. So if we save this file now and run it, we get results of the 2016 referendum. That's one way to format strings. We can also use the format method on the string object. So let's say we have yes votes equal 42,572,654, and we have total votes equal 85,705,149. Then we can say the percentage is yes votes divided by total votes. We could say print curly braces colon -9 yes hold on, yes votes curly braces column 2.2 percentage sign, then dot format, and then we pass yes votes and percentage. Now we need to take away this f in front because we are using the format method, not the f string method. So if we run this now, what do we get? We are getting an error here. Okay, it's import. We imported something, we don't need this. Now let's run it again, and we get 4,042,572,654 yes votes, which is 49.67%. Now, for in this example, you notice that the yes votes are padded with spaces and a negative sign only for negative numbers. The example also prints percentage multiplied by 100, and then we have two decimal places followed by a percentage sign. Now, the third way that we can print strings or we can format strings is by doing so manually. If we do not need very fancy outputs, we can quickly display some variables for debugging purposes using the REPR function or the str function. The str function is meant to return representations of values which are fairly human readable, while the REPR function is meant to generate representations which can be read by the interpreter or will force a syntax error if there is no equivalent syntax. For objects that don't have a particular representation for human consumption, both the str function and the REPR function will return the same values. Many values such as numbers or structures like lists and dictionaries, they have the same representation for both functions. Strings in particular have two distinct representations. Let's take a look at some of the examples that we have for manual formatting of strings. So we can define a string here, say hello world, and here we could say we could print strs and we'll print it properly. And what do we get? We get hello world. But if we do this with REPR function, we get a different format. Let's see how that looks. REPRS column REPR, and if we run this, so you see the difference between these two is that for REPR there is a quotation mark around, there are quotation marks around the string, while for str it's just the plain string that is displayed. Now let's see some other examples. We can also print the output of an expression, so let's do that. Print this. Let's give it a label str1 divided by 7. And let's run this and we see 0.142 and so on and so forth. Let's add a column here. So we get the idea. We could also print out a concatenated string based on some other variables. So let's define x to be equal to 10 times 3.25, y will be equal to 200 times 200, s is equal to the value of x is plus REPR x and plus comma, and y is plus REPR y plus ... Now we can print s. Let's comment these previous ones so we get to see this clearly. The value of x is 32.5, which is the result of 10 times 3.25, and y is 40,000, which is the result of 200 times 200. The result of the REPR function is a string that adds quotes and backslashes. So for example, if we have a string, say hello world, like this, with this special character /n, and we get the REPR of that, REPR, and then we'll pass in hello into it as an argument. When we print hellos, it would still retain this /n. Let's comment this out and see. You see, it retains /n. Now let's see what happens if we just print hello. Let's see the difference. Notice that the second one does not retain /n, and it is basically interpreting the / by taking the cursor to a new line, and that's why we have this extra space here. We're going to explore these three ways of formatting strings in more detail. Let's begin with the formatted string literal. So the formatted string literal is also referred to as F strings for short. They let you include the value of Python expressions inside a string by prefixing the string with uppercase F or lowercase f, and writing expressions in between opening and closing curly braces. An optional format specifier can follow the expression. This allows greater control over how the value is formatted. Let's take a look at some examples. So create a new example file here. Example 2.py. Here let's import math. Now we can print the value of pi is approximately math.py column 0.3f. So let's save this and run it. Example 2, and we get the value of pi is approximately 3.142. If we increase this number here, it gives us even more significant figures. Let's make it 5 so that it's obvious. So we get more significant figures from the value that we are trying to print. Passing an integer after the column will cause the field to be a minimum number of characters wide. This is useful for making columns line up. So let's say, for example, I'll comment this out for now. We have a dictionary object that's defined like so. 4127 and Jack 4098, decab 7678. Or can say for name, phone in table.items column print name 10, and we put a line here pointing to the next item that we want to print. There will say phone 10D, and if we run this, we see that everything is lined up as we specified. Other modifiers can be used to convert the value before it is formatted. Exclamation point E applies ASCII, exclamation point S applies string or str, exclamation point R applies REPR. For example, let's amend this one. Can define another variable here, say animals equal to eels, and print my hovercraft is full of animals. And if we should print this, we get my hovercraft is full of eels. Why? Because we've defined this variable to be eels, which we passed in here. But if we should add the modifier, hold on, let's just duplicate this, and we add the modifier here, exclamation point R. Let's take note, let's see what's different. Yeah, the difference is that the eels has a quotation marks around it, rather than not having it in as in the previous example. Quality sign specifier can be used to expand an expression to the text of the expression, an equal sign, then the representation of the evaluated expression. Let's see an example. You can say bugs is equal to roaches, count is equal to 13, and location, or rather area, is equal to living room. Now we can print debugging bugs equal to count equal to area equal to, and if we run this, we get debugging. We need to add G here. Let's run it again. We get debugging bugs equal roaches, count equal 13, area equal living room. Let's look at the other method of formatting strings, which is the string format method. A basic way of doing this is to just call the format method on a string. Let's take a look at an example. Example 3. We can do something like this. Say print we are the who say, then we do format, then we pass in nights and ni. So we have to remove this F on the front because we are using this format method instead. Notice that we put in opening and closing brackets in the string. This tells Python where we want these values that we are passing in as arguments to go. So if we run this now, you see we get we are the knights who say ni. The brackets and characters within them are called format fields, and they are replaced by the objects that are passed into the format function. A number in the brackets can be used to refer to the position of the object passed in the format method. So for example, we could have something like this, where we say print 0 and 1, and then we format that and pass in spam and eggs. And then we could also have the same thing again. Hold on. We don't need this F here because we are using the format method, not the F string method. So here we can change the order of the values. I have 1 at the beginning and 0 after it. And if we run this, So in the first instance, we have sperm coming before eggs, and in the second instance, we have eggs coming before sperm. And the reason for that is because the number that we put in matches for the values that are being passed into the format method as arguments. So 1 will be the second value and 0 will be the first value. If keyword arguments are used in the string.format method, their values are referred to by using the name of the argument. Let's see how that can be used. We could say, for example, print this food is, or rather we say this food is adjective. We'll say dot format, then we pass in food equal to sperm, and then adjective equal to absolutely horrible. And let's make this come down. Absolutely horrible. We don't need this F here, so take it off. Now if we print example 3, we see this sperm is absolutely horrible. That's because the keyword arguments that we've passed in here have taken place of the keywords that we put in the string that we are trying to format. Positional and keyword arguments can be combined arbitrarily. We can actually combine the numbers and the keywords. Let's see an example of that. We say print the story of 0, 1, and other. Then we say format Bill Manfred, and then order, the value will be equal to George. Save. Let's take out this F. The story of Bill Manfred is supposed to be Manfred. The story of Bill, Manfred, and George. If we have a very long string, it's very difficult to be passing each of these values one after the other, and that's why Python allows us to simply pass in a dict and use square brackets to access the keys. An example of that is what we have here. Let's say table is, let me use John here, column 4127, Jack, column 4098, and then we have, let's say Deborah, column 8837678, and we can print Jack as 0, Jack, column D, and semicolon. We could print John, okay, it's not supposed to be closed here, it's supposed to be closed at the end here. So we could print John, column 0 John colon D, and last but not the least, we could print Deborah colon 0 square bracket Deborah colon D. Now we can now say dot format. I'm passing the table, which is the dictionary that holds the values. Again, get rid of this F, and if we run this now, we get all the values. It's also possible to do the same thing by using the asterisk notation on the dictionary, which is going to just expand the dictionary. That way we can just use the keys directly. So let's proceed. Let's see an example of that. We can see table. Hold on, let me just pick this table definition from here and paste it. Then we can now say print Jack colon Jack D, and instead of typing, we can copy this as well. The only difference we are going to have here is that we don't need the 0 square brackets. We don't need all these. And we have to add asterisk here. And if we run this, we get the same value as we did before. We can use this in combination with the vars function, the built-in vars function, which gives us all the local variables that has been defined. So let's just keep this table here, or comment this part, and let's do this example. Table K column strv for K comma V in vars dot items, and define the message as an empty space dot join, and then we have F, let's just say K in curly braces, then set colon in front of it, plus opening curly braces, let's take this one out, plus K, plus closing curly braces, semicolon, for K in table dot keys. So what we are doing here is we're constructing a string representation of this dictionary that we have defined here, such that it can be written as an output. So let's format this now. Can now say print message dot format asterisk table. And here we get all the names that have been defined in this script. So if you notice, we get even our table here that was defined, and we see all the values in the table. This table that was defined here, we see all the values that are inside, which is really nice. Don't worry if you don't get any of this. As we continue to use some of these features, it will become clearer and clearer An example of a way that we can use this is to produce a tidily aligned set of columns giving integers and their squares and cubes. So let's do that. We can say for x in range 1, 11, column print 0, column 2d. Hold on, this has to be in single quotes, 2d, and then 1, column 3d, and 2, column 4d. Dot format x comma x times x comma x times x times x. And if we print this, we get our columns. Hold on, we have to remove this f from here. Yeah, so we get tidily arranged columns based on what we've written here. Now, looking at this, something that comes to mind that we could do with this is to create a multiplication times table. So let's see an example of how we could do that. Let's do one for the 2 times table. So we can say norms is equal to list of range from 1 to 13, and we can now come in here and say for x in norms print 2 times, let's give it a number here, is equal to, let's give another number here. So we can now come in here and do format x comma x times 2. We don't need this f here. If we do this and run it, we get 2 times 1, 2. Let's give some space so that it's clearer. Right, let's run this again. We get our values 2 times 1, 2, 2 times 2, 4, up to 12. Now, the reason why we use 1 to 13 is explained in a previous video where we looked at the peculiarities about lists. If you've not already seen it, it will be very good if you go back and go over it. The last but not the least way that we can format strings, which is by manually formatting those strings. So let's create a new example file here, example 4.py, and here we can do this same example that we just did, but this time around we are doing it manually. So we'll say for x in range of 1, 11, print repr of x dot r just 2 comma repr x times x comma, we have to put dot r just 3 here, comma end equal to space. Now take note the use of end in the previous line, then print r EPR x times x times x times x and dot r just 4. Now if we print this, if we run this example 4, example, let me rename it, sorry, so we say example 4, we get the same output as before. Now this is very important that we add this space at the end here. It's a feature of the split function that allows us to give space in between the outputs that we are printing to the screen. If we should remove it, so we remove this, it would distort the layout that we have. This is no longer as clean as the previous one. That's why this is very necessary. The string.rjust method of string objects justifies the string. Write justifies a string in a field of a given width by padding it with spaces on the left. So if you notice here, we have some spaces on the left here, and that is being done by this rjustify, because we are justifying it to the right. We also have ljust and string.center, which justifies to the left and center accordingly. These methods do not write anything, they just return a new string. If the input string is too long, they don't truncate it, it just remains unchanged. It will mess up the column layout, but it's usually better than the alternative, which is lying about a value. If we need truncation, we can do something like this. There's another method called string.zfill, which pads a numeric string on the left with zeros, and it understands both plus and minus signs. So let's see that example. Imagine we have something like this. We want to print 12.005. If I run this, I get 3 zeros and then 12. Now you notice that we have a total of 5 characters here, which is what we defined, we passed in as the argument of the zfill method. And so that tells us that the argument that we pass in here will be the length of the output that we are getting. Let's see another instance. Let's say we want to print minus 3.14.zfill 7. If we run this, so we get two zeros, then 3.14. And if we count the number of characters here, we have 1, 2, 3, 4, 5, 6, 7, which matches the input that we pass in. Now suppose we have a very long numeric string, for example 3.1415265359.zfill 5. If we run this, we'll notice that the characters remain unchanged, and the reason for that is because the length of the string is larger than the input, the argument that we passed into the zfill method, and that's why it just uses the string as is without any modifications. We also have an old way of formatting strings using the modulo operator, and it can be written in the form of format, modulo operator, and then values, where the format is a string. Conversion specifications in the format are replaced with 0 or more elements of the values. So let's see an example of that. We'll create a new file here, example 5.py, and in here we could say we import math, and then we can say print the value of pi is approximately percentage 5.3 f, and then we have modulo math.py. And if we clear this and run example 5, we get the value of pi is approximately 3.142. We could increase the number of significant values by increasing this value here. Let's say 6. Run it again and we get 6 significant values. If we increase the value here, that's the value that comes before the dot, it increases the number of spaces that is given before the output. So for example, if we run this now, we get, hold on, I need to save this, run this, notice that there is some padded spaces before our actual value. And that's it for fancy formatting of outputs, especially strings. Remember to like, subscribe, and share. In the next episode, we're going to be looking at reading and writing files. I'll see you there. Bye.